says Jennifer traveled to her friend's house and back. That's a key sentence. That's a key sentence. You're traveling, let's say you're traveling to a friend's house and you're traveling back. Though they're two different routes you're taking, if you travel somewhere and you travel back to the same place where you started, the distance that you travel there is the same as the distance that you're traveling to get back. That's key in the problem. That's key in this problem. So let's say you're starting here, Jennifer. Let's call this the distance there. Let's call this the distance there. All right, and let's call this the distance back. It's the distance back. All right. Jennifer traveled to her friend's house and back. It took 2 hours less time to get there than it did back. It took 2 hours less time to get there than it took to get back. All right, so what that means is that maybe it took 6 hours to get there. All right, it took 6 hours to get there, but it took 2 less hours to get back. All right, so if they say it took 2 less hours time to get there to get back, so that means let's say if it took 6 hours to get there, well, it took 8 hours to get back. But let's say it took 10 hours to get there, well, that means it took 12 hours to get back. But see, the challenge is you don't know how much time it took there. So the way we write that mathematically, if it took 2 less hours time to get there, the way we're going to write that mathematically is, you know that you've got distance is equal to rate times time. These are the kind of problems we're working on. Distance is equal to rate times time. It took 2 less hours to get there. So let's call the time to get there t. All right, let's call the time to get there t. All right, but it took 2 less hours time to get there. So it took 2, this time is 2 less than this. So let's call this time t plus 2. You don't know the times, that's why you have to use variables. All right, so it took 2, it took 2 less hours to get there. So let's call this t. This t has to be 2 less than the time to get back. So that's how we write that mathematically. All right, so the average speed on the trip there was 60 miles an hour. So they give you the rate. Another word for speed is rate. So let's put 60 there. They told you that the average speed there was 60. So I substitute the rate to be 60. The average speed back was 40. So this is our back speed. Let's put 40 there. All right. So the distance there can be calculated by taking 60 times t, and the distance back can be calculated 40 times the sum of t plus 2. All right. So it says, how many hours did it take to get there? Well, to solve for time here, I'd like you to observe the first sentence that we reference. It says, Jennifer traveled to the friend's house and back. I told you that that's important. That first sentence is important because the distance there is going to be equal to the distance back. All right. So what you can do here is set up an equation that this distance, which would be 60t, has to be equal to the distance back, which can be, we said was 40 times t plus 2. All right, so you just set up an algebraic equation. Again, you have a problem that involves both algebra, distance equal to rate times time, and a relatively decent diagram. Solve this algebraic equation, you end up with 60t. You distribute the 40, you're left with 40t plus 80. Distribute the 40 there. You subtract 40t on both sides. Subtract 40t on both sides. You're left with 20t is 80. 20t is 80. Uh-oh, cut off a little bit. So you divide by 20 on both sides, and you're left with t is 4. The time it took to get there was 4. And let's see what they asked for here. Yeah, how many hours did the trip there take? So that's the final answer. If they would have asked you how long did it take to get back, you would have taken this 4, you would have substituted this 4 into t plus 2 to get 6. If they would have asked you what was the total time the trip took, you would have had to add the t, which was in this case 4. The time it took to get there would have been 4. The time it would have taken to get back would have been 4 plus 2, which is 6. You would have added those times to get a total time of 10. So there are a variety of questions they could have asked you on that one problem. Again, this is the kind of problem you'll see on a PSAT, ACT, SAT, or even GMAT problem. It involved, as you saw, it involved a good diagram, which is a skill. It involved knowing that this was a distance is equal to rate times time problem, and it even involved algebra. It involved 3 different techniques in the context of one problem. Very, very common in a lot of these standardized tests, and we want you to be successful on these standardized tests. So how are you successful? You would have to study. You would have to study. And I have defined studying. In the past, I've defined studying for math as redoing a lot of these problems. You're redoing a lot of these problems. Problem after problem after problem, you're redoing where you are aware of the answers. You're aware of the answers, you redo the problems, you get the answer to these problems, you do problem after problem after problem, you get more and more comfortable, and next thing you know, there's a stack of problems you've done in preparation for a test, and you'll discover that you will dominate that test. This is why we call this show Students Dominate Math. The goal is domination. You dominate math by doing problems. Number 7. By studying. It's number 7. Crystal left Julio's house 4 hours before Kim did. So the way I'd interpret that is Crystal has been traveling for longer than Kim has been because she left the house earlier than Kim, 4 hours earlier than Kim. So Crystal might be on some type of path traveling for 5 hours, whereas Kim has only been traveling for 1 hour. All right? Or possibly Crystal has been traveling for 10 hours, whereas Kim would be traveling for only 6. Crystal has been traveling 4 hours longer than Kim. That's important as we attack this problem. They drove in opposite directions. All right, so again, you're dealing with a problem where let's draw a good diagram. All right, let's draw a good diagram. And what we're doing here is we're going to say that Crystal, this is Julio, and let's call, they both begin with K, so let's call Crystal Y, and let's call her M. Also, I hope you've noticed that I've strategically labeled and identified these variables. I'm not just using any variable. I think your problems are simplified if, Crystal, her name has a Y in it. Kim, her name has an M in it. So you strategically label the variables to give you an idea of who you're talking about. All right, so Crystal left 4 hours before Kim did. They drove in opposite directions. Kim drove 60 miles an hour for 2 hours. So again, distance is equal to rate times time. Kim drove 60 miles an hour, 60 miles per hour for 2 hours. 2 hours. So you get the distance that Kim traveled to be 100, and hours cancel, 120 miles. 120 miles. All right, after this time, after what time? Well, after 2 hours time. After 2 hours' time, they were 420 miles apart. So this problem is very, very similar to the one we did previously. All right, so after the 2 hours have passed, this distance apart between Kim and Crystal is 420 miles. 420 miles. All right, so this total distance is 420 miles. Well, if Kim has traveled 120 miles, Kim has traveled 120 miles, and they tell you that after the 2 hours have passed, the distance between the two young ladies is 420. Hopefully you can see that if this distance is 120, the way you'd get the distance that Crystal has traveled would be just simply subtracting 420 and 120, which would be 300. All right, so you got distance is equal to rate times time for Crystal. Distance is equal to rate times time, but you can calculate the distance that Crystal has traveled by taking the difference of these two numbers, which is 300 miles. All right, 300 miles is equal to the rate times the time. Now the time that Crystal was traveling, they said that Crystal had left 4 hours before Kim. So if Kim was traveling for 2 hours, and Crystal left 4 hours before, that would mean that Crystal was traveling for 4 hours more than Kim, which would be 6. 4 more than 2 is 6. So now you have a basic algebraic equation. 300 is equal to R times 6. You solve by dividing by the term next to what you're solving for. You divide by 6 there on both sides, and you get the rate is 50. You get 50 miles per hour. 50 miles per hour, final answer. 50 miles per hour she was traveling.